Welcome back to Yijin Hardware. Today we will discuss how to choose inserts for profiling turning, which is also known as contour machining. Unlike axial and face turning, contour machining often involves numerous protrusions and recesses, angles, and arc structures. To successfully machine the product structure, tool selection is crucial. If the tool nose angle is too large, it can cause the main and secondary cutting edges to overcut the workpiece, leading to machining failure. Therefore, before selecting the tool, it is necessary to analyze the shape and dimensions of the workpiece. First, we need to identify the workpiece's maximum overcut angle. For example, in the video, the workpiece to be turned is a ball head made of 40 CR material with a hardness of about HRC 30 after rough machining. First, we need to determine the minimum principal cutting angle that can be used to machine this part. By examining the various angles and tangents along the cutting feed direction, the red line segment represents the limit position of the main cutting edge. We find that the minimum principal cutting angle of 60 degrees just avoids overcutting the workpiece. Similarly, the minimum secondary cutting angle is 70.5 degrees, represented by the blue line segment indicating the limit position of the secondary cutting edge. The sum of the principal cutting angle, tool nose angle, and secondary cutting angle should equal 180 degrees. Therefore, the tool nose angle must be less than 49.5 degrees. A standard 35-degree V-shaped insert fits perfectly. Next, we need to pair it with an appropriate tool holder to ensure the CNC tool will not overcut. Here, we select the SVBM tool holder, which has a principal and secondary cutting angle of 72.5 degrees each. This setup allows a single tool to complete the entire ball turning process, reducing the time spent on tool changes. Let's summarize the key points for selecting tools for contour turning. Before machining, prioritize the tool's nose angle, principal cutting angle, and secondary cutting angle to ensure adequate clearance between the tool and the workpiece. Generally, the secondary cutting edge should have at least a 2-degree clearance angle from the workpiece. Additionally, where interference is not a concern, choose inserts with larger nose angles to ensure tool strength and reduce production costs. In actual production, 55-degree DCMT inserts, 35-degree VBMT inserts, and R-shaped inserts are the most commonly used for profiling turning. Subscribe to our channel to easily learn CNC knowledge and make a little progress every day.